Mathematical representation of phasor. Now, a phasor can be represented in two different ways, that is rectangular and polar. We have learned in mathematics Laplace transform, Z transform. So, where we find easy in Laplace transform, we use Laplace transform for equations. Now, if a sign quantity is there in Laplace transform, you know that it is giving first part as answer, and in Z transform it is so somewhat cumbersome. So where we require which transform, we decide by our uh, methodology to be used. That is either to multiply, either to add. Now somewhere in rectangular we have addition very simpler, so we use the rectangular part, while we find multiplication easier in polar, so we go for polar. Now both we need to understand. So today we will going to see phasor in two different ways, that is rectangular and polar form. So instantaneous voltage V of t could be represented as Vm sin omega t plus phi. Now see here both formats are being used. This is our Vm. Now this in rectangular format we note down as R angle phi. Whereas the same Vm part here, from dotted part we are seeing on x-axis at x and dotted part on y-axis as y. So these two formats are angle phi and x plus jy. This x-axis is now called as real axis, whereas in complex you know that the y-axis is, here we have the complex part. So while writing, what we do is, see, polar format we write down as r angle phi, whereas rectangular format we write down as x plus jy.